Hello, great learners. Welcome to my channel at Science Guru Exam Drills. I am pleased to host you in another learning segment today. As you all know, Cambridge Assessment International Education is an international exam that carries out the checkpoint test for primary learners as well as lower secondary and all the way to the IGCSE and the A levels. But for today, we're going to focus on Cambridge Primary Checkpoint, as you can see on your screen. And this particular paper is the paper 2, Cambridge Science, October 2021. You should have it in mind that paper 1 and paper 2 is done under 45 minutes each. So you have a total of 90 minutes to complete your exam when sitting the Cambridge Primary Checkpoint. You should also note that the exams can be very dynamic. Cambridge might repeat questions across different concepts taught under primary science, but the question structure can never be the same because it will always come differently per year. But there are some of them that when you practice over time, you begin to gain an algorithm or a particular pattern around them. And when you see any tweaked questions around that topic or concept in any area of science, be it the biology strand, the physics strand, the chemistry strand, the earth and space strand, and the scientific inquiry, you should be able to attempt them without fail, and that will guarantee you to gaining your expected outcome. Of course, this channel is meant to help you pass any science exams without stress, but you must commit yourself to studying, to following the patterns, to studying more YouTube videos on solved past questions, and a lot of other additional tasks you need to put in place to ensure you have a flying color. So let's get down to business. The first question before us is a question under the biology strand of science. So let's study the question and attempt the answer. Question 1A says Oliver has two groups of animals. So take note of two groups. It means we have to do some comparison, comparative study, and some matching processes. Group A has the bat, the butterfly, the duck, the earthworm, the dog, the cat, and the tiger. So let's study these animals by their body structure first so that we can get clues as to what the question will be demanding from us or from you as the candidates that will be sitting these exams anytime soon. So the bat here is a mammal. The body structure, as you can see, it has wings attached to the body. It has other parts of the body like the head, the limbs, and all that. The butterfly here is in the insect class. It has wings. It has the body where the wings are attached to. Then the duck here belongs to the class Aves or the birds family. You can see it has a beak, the head, it has wings as well and covered with feathers. Then we have in group B, earthworm. The earthworm is limbless, does not have limb, and does not have a wing also. The dog here has limbs, even though this picture is not a complete one. You can see the tongue, you can see the nose. Then we know dogs have fur on their body. Then we have the cat here. It has limbs, it has a tail, it has fur covering its body. Then we have the tiger. The tiger also possesses limbs, body is covered with fur, and it has other body parts or features. Now, having studied that trend, the question says write down one feature that Oliver uses to put the animals into these two groups. So what characteristics or features do you think Oliver considered to place them into this group where bat, butterfly, and dog belongs to group A, while group B has earthworm, dog, cat, and tiger? So one of the quickest answer is the idea that group A possess wings, while group B has no wings. This is the probable reason why Oliver placed them in that category. Or you could also say group A does not possess limbs, while group B possess or have limbs. The limbs has to do with their hands and legs, the forelimb and the hind limbs. So any of these two responses will fetch you 1 mark. I believe you're noting that down in your writing pad. Now let's move to the next question. The B part says, look at these animals. We have the gorilla here. We have the snail here, We have the snake, the frog, the horse. Oliver puts these animals into two groups. Still further classification. Complete the table. Two have been done for you. So he placed frog from this list here under group C. So frog has been taken. He placed it under group C. Then he placed the animal snake. So snake has been taken. Snake under group D. So the question now is, Oliver puts these animals in two groups. Complete the table. So we need to use our idea of the comparison or comparative study or the decision tree, where it gives us a guide to use probing questions like, does he have limbs? Does he not have limbs? Does he have wings? Does he not have wings? Does he have fur? Does he not have fur? And many other physical characteristics we can use to compare these organisms. So if I take a look at frog very well from the picture, frog has a slimy body. It has fore and hind limbs. And in terms of its habitat, I can say it lives mostly in water and also can share its life on land because it's an amphibian which lives a double standard life. Amphi means double in Greek. Then let's look at the snake. The snake does not possess a slimy body, but rather possess scales that covers its body. It is limbless or does not possess limbs. And I can say the snakes live mostly on land or terrestrial habitat. Then sometimes we have water snakes as well. So we're going to compare the remaining three animals and place them in the right order. So from this analysis, which animal goes with the frog in terms of its physical structure and shape, if you want to consider that as well? So considering the snail does not possess limb. So the snail will rightly go under group D because the snake is a limbless organism. So I'll write snail here. Then going back to the diagram, let's look at the frog again. Frog possesses limbs. Then considering animals in this picture that has limbs, the gorilla has got limbs. So I'll place gorilla under group C. Gorilla. Then I'll go back again. Gorilla has been taken. So I'm just doing this so that I will not mix things up. Now I have a horse. The horse is the last but not the least for consideration here. Where do you think the horse will fall? It also possesses four limbs and hind limbs. So I'll also bring it under group C, the horse. If you're able to do this in this sequence or correct order, then you earn the 1 mark allocated to that question. Okay, let's move to question 1C. 1C reads, write down the feature that Oliver uses to put these animals into these two groups. So from what we just did in 1B above, he placed these animals under group C because they all possess limbs or legs. In group D, they don't possess limbs, or you can say they are limbless. The idea that group C possess or have limbs, while group D does not possess limbs, or you can say they are limbless, does not possess limbs. If you do this, you earn the 1 mark. You can also come in to say group C has legs, group D does not have legs, and so on and so forth. Question 2. Mixtures are separated using different methods. Draw a line between each mixture and its correct separation method. So this simply takes you back to the chemistry strand, and the topic is separation techniques or separation methods. And recall your separation techniques. There are many of them. We have the filtration method, distillation method, sublimation method, chromatography method, fractional distillation, filtration, magnetization, sieving, hand picking, and so on and so forth. So hinging on that basic knowledge as taught in your previous classes, most especially in year 10 SS1 and partly at the lower secondary, you will discover that there are different methods we can use to separate mixtures that are either temporary or permanent, or we can use them to separate mixtures that are either chemically combined or non-chemically combined. So let's study the mixtures and the separation method we are given. Note, more than the required separation method has been given here, some of them are distractors, so you need to pay attention to the particular mixture we have at the left hand side, then the separation method or technique at the right hand side, and match them correctly for 1 mark each. So when we have iron powder and aluminium powder together, how can we separate that mixture? Iron powder and aluminium powder, how can we separate it? So the first question is iron powder. So that is like iron filings or iron that is chipped into tiny particles. And aluminium powder, if you notice, one of them is magnetic, the other is non-magnetic. So simply put, from that basic idea, we will use a magnet. So this arrow goes here. You can use a ruler to do this neatly when you are sitting for this exam. Then the next mixture here is sand and salt. So when you have a mixture of sand and salt, which method is the best separation technique here? Is it to dissolve in water and filter, burn the mixture, evaporate the mixture, melt the mixture, sieve the mixture, or filter the mixture? So in order not to be distracted, go back to the mixture again. Sand is insoluble. Salt is also solid but soluble in water. So what is the best method that you could use to separate this mixture? It will be to dissolve in water and then later filter. So it goes like this. Now how do you do that? When you dissolve this in water and you filter, the sand will be retained in the filter paper, while the liquid that goes through the filter paper into the empty container will have the dissolved salt. Then if you want to further recover that salt, you can now use another method such as evaporation method. But for this question, it's simply to dissolve in water and filter. Next mixture, salt solution. Salt in water. Salt is soluble. So you now have a water that has the same phase with the solid that was dissolved in it. So which method can we use to separate this mixture? I believe you're guessing the answer right now. The answer would be to evaporate the mixture. Then where you have sand and water, we only have how many options left to pick from? Burn the mixture, melt the mixture, sieve the mixture, filter the mixture. So when you have sand and water, what do you do? Will you melt it? That's not the right answer. Burn the mixture, it will not give any solution to that. Will you sieve the mixture or you filter the mixture? So the answer would be filter the mixture, because when you filter it, the sand will remain at the mesh of the filter while the water will trickle down into the empty container and you have two separate substances. Then we have the last but not the least, lumps of marble and powdered marble. What method will best separate this? Is it to burn the mixture or melt the mixture or sieve the mixture? Of course, lumps of marble is a solid substance and powdered marble. So lumps of marble are in form of lumps, like they are sizable and can remain in the mesh of a sieve, while the powder can go down the mesh of a sieve into an empty container. So the right answer to this would be to sieve the mixture. So when you do this, each one goes for 1 mark and you get a total of 5 marks in this order. I hope you found this helpful. You can now note this in your writing pad. Mostly when you see a question like this, take your time and first study the mixture. Study the substances that forms that mixture. Is it existing in solid state, liquid state, or gaseous state? Then from that idea, you begin to think and relate it to the most probable or best separation technique or method that can separate it, so that you can have two different substances clearly separated by the aid of those separation techniques. All right. Moving to question 3, complete the crossword puzzle. There are clues. Number 1 down on the puzzle, weight is measured in dash. Number 2 down the puzzle, that's vertically down, Weight is a type of dash. We need to complete the blank space. Then question 3 is across. That's horizontally across the puzzle. Mass is measured in dash. So owing to the concept of masses, weights, and forces in nature, you have to go back to fundamental units and fundamental quantities, then units that are used in measuring different quantities in nature. So if you go back to that basic concept of forces, weights, and masses, the question is asking in what unit do we measure weight? So we go. I hope you're thinking of the answer right now. I want to start writing. Are you ready? So weight is measured in newtons. So pick the pen, Newton. And most times we write the symbol of the unit as capital N. So either way, you end the mark. Then down vertically on the puzzle, weight is a type of, is it energy or force? The answer is a type of force. Weight is a type of force. So I'm going to expand it now for us to see. Weight is a type of force. So F O R C E. Then 3 across, that's the third option. Mass is measured in what unit? The answer is kilograms. Then we use the symbol capital letter K and small letter G, just in case you want to put the symbol or if it's required. So number 1 is Newton. So we're going to fill in this puzzle with N. I need to expand it again. I need to expand it. So I have letter N here. Let me make it a bit zoomed in. So here you have N, E. This is what you have to do. N, E, W, C, O, N. Newton. You can also put it in plural form, newtons. Then number 2 down or vertically is the word force. So write the letter F here. F O R C and E. Remember when we used to do puzzle growing up? We were trying to look for the missing words. We were trying to rack your brain in order to get the puzzle grids filled up. And once you're done and you got it correctly, then you're happy. Then here we have kilograms. So that's exactly what we're doing here. So this will go K, fill it across or horizontally. Kilograms. R A M S. So doing this correctly in this order, number 1 is newtons, vertically downward or down. Number 2 is force, vertically downward or down the puzzle. Number 3 is kilograms, horizontally or across the puzzle. And when you do that, you earn your 3 marks. I hope that is clear. You can note that in your writing pad. Okay, let's move to the next question. That will be question 4. Question 4 is in the biology strand of science. Question 4 says the parts of a plant have different functions. Of course, that fact has been established. Different parts makes up a plant and they each carry out specific roles and functions in order to keep the plant alive or in a livelihood environment. Now, draw a line from each part to its correct function. So this is to test your matching skills and how you can give descriptions for each part or component of the body of plants being a living thing. We have different functions that have been randomized for us to cross match. So one of the functions here says takes in light for reproduction, transports water, takes water in, and all this goes for 2 marks when correctly done. So let's start with the first one here. I usually tell students to take out time to understand first what each part of the plan does. You have to start reminiscing it or recalling that in your memory. Then you look at the question again, pick one part at a time and compare or match with these 4 to see which one best fits or best describes it. So flower, does it take in light? That is not its major function. For reproduction, yes. So flowers are actually produced at the maturity stage of plants in order to reproduce both seeds and fruits. So that is why we have the answer as this. You can use a ruler to do this neatly. This is because I'm using my freehand sketch with my writing pad. Okay, so the next part of plant here is leaf. The leaf, does it take in light? That is not the function of the leaf, which is the kitchen of the plant as otherwise portrayed. The next part of the plant in view here is the leaf. Plural is leaves. And the leaf serves important role and function in the growth and development of plants. So does the leaf take in light? Yes, it does that through the help of the stomata on the leaves. So you cross like this. Then we have the next part here, root. Does the root transport water? Absolutely no, but it takes in water, and not just water, it also takes in nutrients or minerals from the soil. So you cross this way. That's just for additional information. Then stem. The stem connects from the root upwards and hold the branches and other important parts of the plant. So it does the upward and downward transportation or movement of water and nutrients in the body of plants. And it uses, pressure from the soil. It uses the capillary system or the capillarity pressure, and it does that through different tissues, which I will not go deeper right now based on the exam requirement. All right, so you cross it like this. So I have this cross. When you do that, you earn 2 marks. I hope that is insightful. You can also pause the video at intervals to redo this yourself so that you can gain mastery in case questions that are similar to this pops up in your Cambridge Primary Science checkpoint. All right, moving on. Question 5 is the chemistry strand of science, and the question reads, copper sulfate is a blue solid that dissolves in water. Take note of the color of copper sulfate. It is blue in color. That is in terms of its appearance. Because when you're dealing with substances in chemistry, you have to look at their physical properties, you have to look at their chemical properties, and other properties that defines them to be the elements, the molecules, or the compound they are. So copper sulfate here is a blue solid that dissolves in water. You can also look at the appearance of substances in most analysis. You also look at their structure, you look at their state of matter, is it solid, liquid, or gas, and so on. The question now demands complete these sentences about copper sulfate dissolving in water. Choose words from the list. So a word bank has been provided. We have insoluble, we have soluble, solute, solution, solvent. So these are vocabularies that goes with the chemical reactions that happen between substances in the environment or in a chemistry lab. Now let's go on. Copper sulfate is dashed in water. Is it insoluble? Is it soluble, solute, solution, or solvent? Now, for you to be able to attend these questions, you must go back to the properties and the characteristics of compounds in nature. And having studied copper and its sulfate, you can tell if it dissolves in water by engaging in the practical aspect of it. So this has to be carried out in the science laboratory, and I believe by now your science teacher should have carried out that experiment. So copper sulfate is dashed in water. It is actually soluble in water. So soluble. Copper sulfate dissolves in water to form a blue. Is it insoluble, solute, solution, or solvent? When you dissolve a solid substance in a liquid, what do you call the product formed in that container? So it is going to be, it forms a blue solution. So this is what we're going for, blue solution. Blue solution. Okay. Now let's go to the third one. It says water is the dash and copper sulfate is the dash. Now, what state does water exist? Water exists in liquid. And what do we call that state when we are dealing with chemical reaction between solid and liquid substances? We need to now go back to the vocabulary. Remember this formula: solute plus solvent is equal to solution. I always tell my students during chemistry sessions that they shouldn't forget this vital formula. You will say solute plus solvent is equal to solution. While solute is a solid, solvent is a liquid, and solution is a mixture of the solute and solvent, or the solid dissolved in the liquid. Alright, so water is the solvent in this case, solvent, while copper sulfate, which is the solid substance, is the solute. S-O-L-U-T-E, solute. So if you can provide these answers in this correct sequence or order, you earn the full free marks. Alright, I hope this makes sense. Put it down in your writing pad. Question 6 is biology strand of primary science checkpoint. The question reads, the platypus has features that are suited to its habitat. For your information, the platypus is the only mammal that has the egg-laying ability. That is to say, among all mammals, the platypus is the only mammal that lays eggs, and it hatches the eggs when the eggs are mature or due. So take note of that, but that's not the question. The platypus has features or characteristics that are suited to its habitat. So you must take note of the features or characteristics that suits it to its habitat or environment. And what are those features? It has a very big beak, as you can see here. It has a thick fur that covers the body. It has a webbed feet like that of a duck and other webbed feet animals. And studying these features, you can quickly analyze what they are used for. Of course, the beak is big and is widened. It is very thick and heavily built. That is simply to grasp or grip its prey and for other grasping purposes. Looking at the fur is natural body covering, and the fur, of course, in that kind of environment, being an aquatic environment, it is usually extremely cold most times. So it requires that fur to keep warm and also to trap in the heat so that it doesn't lose heat from its body. Then the webbed feet, as you can see, it's already adapted for swimming and paddling in water. So these are the basic ideas around the question we have before us. So let's look at the question. A part says, complete the sentences. The platypus has thick fur to dash. So we have to fill in the blank. So from the little analogy I made earlier, what do you think is the answer? To, I'm writing now, to keep warm, because the environment is cold. It's an aquatic environment surrounded with water. You can also say it helps to trap in heat. You can also say it helps it to stay warm. Any of those responses will fetch you the mark. But we need to supply the next answer to earn this 1 mark. It says the platypus has webbed feet to help it, as I explained earlier, my analogy is simply to swim. So I'm just trying to zoom it in at this point, to swim. For swimming in water, or you could say to paddle in water. To paddle. To paddle. P-A-D-D-L-E. To paddle. Alright, so when you do this, you earn the 1 mark here. Now moving on, complete the sentences. The platypus is camouflaged to help it The idea of camouflage is simply to help animals blend in into the environment. So you could say it's to help it blend in. This one goes to blend into its environment. That's what we could simply refer to as camouflage. So apart from blending in, you can also say it helps it to stay hidden in its environment from its predators. It helps it to also stay hidden from its prey because they also use that to lay attack or ambush for their prey in order to feed in their environment or habitat and so on. So any of those can go for this. Then the platypus has a big beak too. Simply is to grasp, G-R-A-S-P, to grasp, or you can say to grip prey or food. To grip prey or food. Alright, once you supply this in, you earn your 2 marks. Alright, you can pause the video at intervals to study this on your own again in order to gain mastery. Okay, let's move on to question 7. Question 7 is a question that is drawn from the topic light. This is from light and its effects in the environment. Light as a form of energy and even the method in which light travels, which is called the rectilinear propagation of light. Light travels in a straight line. The idea of when light rays is blocked by an object, it forms a shadow, or a shadow is cast. The shadow is always a dark outline of the original object blocking the rays of light. So the question says, draw a line from the word to the correct meaning. So we're looking for the best meaning that describes each of these light vocabulary or words used in the study of light. So the words here are opaque, reflect, shadow. Then we're looking for the best word that describes. If you notice, there are 4 options here. One of them is actually incorrect and it serves as a distractor. So your focus should be, what is the actual definition or description for opaque? What is the best description or meaning for reflect? Also, what is the best description or meaning for shadow? So we're going to take our time to read this meaning one after the other so that we can match it properly before we draw our matching line. So are you ready? All right, let's see to it. Now, let's take opaque. In the study of light, an opaque material is generally any material that does not allow light rays to pass through it. It serves as a blockage and the surface does not allow light to be able to pass through. Most dark or black substances serve as opaque materials. So with this idea, let's read the meanings here and see which one matches. Now, dark shape that appears on a surface when light is blocked. Is that opaque? No. My earlier definition has that as what? Shadows. So I can just go straight and pick my shadow. It just depends on which one you want to start with. But this meaning best describes shadow. It's a dark shape that appears on a surface when light is blocked, from my earlier illustration. Then if you move on, the next meaning here says material that lets light through. Is it reflects? The answer is no. Is it opaque? No. So this is actually the distractor here. I can already figure it out because material that lets light through are called transparent material. That's under the qualities or characteristics of light. We have transparent materials which allows light to pass through them. We have opaque materials like we have here, which does not allow light to pass through them. Then we have an in-between called translucent quality. It allows only little amount of light to pass through, like when you drop oil on the surface of plain paper or A4 paper, it will give you a translucent look. When oil drops on any book or paper surface, that coloration you get is a translucent material. So those are under the qualities or characteristics of materials under light. So this one is ruled out. Now let's go for the next meaning. Material that stops light going through. So already you know that is going for opaque material from our earlier illustration of basic idea about light, materials and qualities. Then the last one here says what happens to light when it hits a mirror? The answer is reflects. So if you do this correctly, you earn the 2 marks allocated for this question. All right, take out time to still do this on your own and pause the video at intervals. The B part of this question says, Sophia is looking at a flower. So this is Sophia here. This is the sun above her head or in the sky. Then this is a flower in the environment or a particular habitat. Of course, terrestrial habitat. Explain how Sophia sees the flower. Now let's quickly do an analogy. In the rectilinear propagation of light, light travels in a straight line. So how does Sophia see the light? Does the sun's rays fall onto the eyes of Sophia before she can see this plant or flower? Or does the rays of the sun falls on this object, which is the plant or the flower in this case, before the rays travels into Sophia's eyes? The ball is in your court. So quickly, from the rectilinear propagation of light and how light travels, the sun's rays will first fall on the flower like this. So it goes like this, falls on the flower. Let's use the arrow sign to indicate the direction of the light. Then this will now be reflected and it goes to Sophia's eye in this manner. So this is how she sees this object. This is just this simple analysis showing how light travels and how objects are seen in the environment. So this goes to our eyes. So using this basic light analogy, sometimes we use broken lines like this to represent the rays of light, depending on how you're doing it. So you just put the arrow to always show direction from the source of light. So this is the source of light, source of light. Then if we were to explain using this model or illustration or analogy as used in science, to explain how Sophia sees the flower, you will say light rays, light rays, light rays light rays fall on the object, falls on the object, and the object in this case is the flower. The flower. Then the reflection, the reflection travels to her eyes to see the object. To see the image. To see the image of the object. If you're able to do this, you earn the 3 marks. And simply put, you can just say Sophia sees the flower due to the transmission of the image of the object or flower when light falls on it. As simple as that. All right, I hope this helps. Moving on to question 8. Question 8 is in the physics strand of Cambridge Science Checkpoint. So it says Yuri learns about how sound travels in different materials. Tick the correct box to show if the sentence is true or false. So we have the sentence, then we have the options here, either to select true or false. So it's a true and false question. So we need to look at the assertions properly. So this is about sound in physics, talking about sound and how sound travels. So recall that matter exists in four phases, but we are mostly acquainted with the three phases: solids, liquids, and gases. So this is trying to give us an analogy of how sound travels through this various medium or through these various media. So sound is a medium, sound is a form of energy, solid is a medium, liquid is a medium, and gas or gases is also a medium in the states of matter. So sound travels in air. Is that assertion true or false? Are you thinking about the answer right now? Sound actually travels in air, so it's true. You tick the box for true. Let's go to the second one. Sound does not travel in water. Water is a form of liquid. Is that true or false? The answer is false, because water is a form of liquid, and liquid is the second state of matter, and sound also travels through liquids. Even when you are in ship and you make a sound, the echo goes to and fro the body of water. When submarines communicate, they also use this medium. Then let's go to the next one. Sound travels in solids. Is it true or false? Solid states also allow sound to travel. When you knock on a wooden door, on a metal door, or you hit on a gong, the sound travels. Then another assertion says, sound does not travel in a vacuum where there is no air. Is it true or false? The answer is true. So all these four correct, you get 2 marks. 3 correct will attract 1 mark. 1 correct will attract no mark. And that is the way the mark scheme has been designed. So when you do this correctly in this order, you earn the 2 marks allocated. All right, moving on to the next question, question 9. Forces make objects move. This is also a physics strand of science. It says, draw 1 arrow on each picture to show the direction of the force. Start the arrow from the large dots in each picture. So there's a large dot that has been indicated on each picture showing different actions. And each of these actions require the use of a force, either a pulling or a pushing force, because force is defined as a push or pull on an object in order to necessitate an effect. It could be to change its direction, it could be to change its shape, and so on. So in this case, one has been done for us. So let's look at the example. That will be a guiding light for us. The ball is kicked. So can you see the direction of the arrow? It is from the dot to the ball, showing the direction of force. Of course, force has a direction. There must be a direction. We have vector quantities and scalar quantities, but forces are vectors. So you must always use an arrowhead to show the direction of the force. Okay, so the ball is kicked, so the force is in this direction, and I can say that is a pushing force, if I may add. The weights are lifted. So in which direction is the force exerted by this weight lifter? It should be this way, upwards, because that is where the hand is pulling from. That is where your arrow should face. Look at the next one. The box is pulled by the boy. So in which direction is the pulling force? It is from the dot all the way to, oh, this is a mistake. Let me erase that. Sorry about that. The line has to be straight. So when you're doing this in the exam, you need to use a ruler to get a neat layout. So it is in the direction of the So it is in this direction. You do the arrowhead. Then when you go down, you have the next one. The trolley is pushed by the girl. The trolley is having a basket carrying some luggages or items. So in which direction is this force? She's pushing forward. So from the dot, the arrow should come this way because it is in this direction. Then look at the hands are moved together this way. The hands are moved together this way. So when you do that, can you see the direction? So my left arm is pushing toward my right hand to give the clap. So the arrow will go in this direction to necessitate that clap and the sound is produced. Okay, the next one says the girl pushes on the wall. Look at the hand of the girl and the dot. So is this arrow going to be backwards or forward? From the dot, it will go in this direction, exerting force on the wall. So when you do this correctly, you earn the 2 marks allocated by Cambridge International Examination. I hope that makes some sense. You can pause this video at intervals to carry out this exercise on your own and make sure you gain mastery. The essence is for you to be able to gain mastery of this concept. It's a physics concept about forces. When you seek repeated questions like this or similar questions, you'll be able to apply this same knowledge to attempt them. Now I'll go to question 10. Diesel is a liquid fuel used in the engines of some motor cars and trucks. This is basically from the chemistry strand of science. The A part says diesel evaporates slowly at room temperature. Write down what happens during evaporation for 1 mark. So I need you to take time to process this question. You can reread it again so that it can make sense and you process it using your critical thinking ability. So let's look at it closely. Diesel is one of the products of crude oil after extraction and processing. Diesel is a liquid fuel used in the engines of some motor cars and trucks. We also use them in generators to generate power or energy. A. Diesel evaporates slowly at room temperature. Room temperature is between 25 degrees centigrade to 30 degrees centigrade or Celsius. Write down what happens during evaporation. So this time around, we are referring to evaporation, which is the escape of liquid molecules in a transformation from liquid to gaseous or to vapor form in nature. And this is necessitated most times by the effect of different factors in the environment. So let's stay on that. Diesel is a liquid fuel used in the engines of some motor cars and trucks. Diesel evaporates slowly at room temperature, which I mentioned earlier, between 25 to 30 degrees centigrade or Celsius. Write down what happens during evaporation. So when you expose diesel in a room at room temperature, what happens in that room? Have you thought about the answer? I know you're processing it right now. I'm going to state the answer. So let's go this way. So the expected response to this question would be that the diesel will change, it will change into gas, or you can say vapor in this case. Simply put, the particles or the molecules of the diesel, which is in liquid form, will change into gaseous or vapor form through the process of evaporation, and that goes for 1 mark. You can also say the particles of diesel will fill the room in form of gas. It will fill up the room due to the escape of the molecules or particles from the liquid state, and that goes for 1 mark. Is that okay? Okay, we'll move to the B part of the question, which says suggest one way to increase the speed of evaporation. How do you do this? It is simply by increasing the temperature. So when you do this, you earn the 1 mark allocated to this question. By increasing the temperature, the speed of evaporation will also increase. You could also say by heating up the diesel with a source of heat. You can also say by exposing it to more wind. You can also say by increasing its surface area, which will also necessitate the speed of evaporation. So this response in any of this manner will earn you the 1 mark. Now I'm going to the C part of the question. It says evaporation is a reversible change. Reversible changes are changes that can be reversed to their original form. Recall, there are reversible or temporary changes and irreversible or permanent changes in chemical reaction, in chemistry, in science. So having that background knowledge, it will help us and give us a clue to solving this. So the question says, name the process that is the reverse of evaporation. So when substances changes to gaseous or vapor states, how can they be returned back to their original form? The expected response to this question is simply the process of condensation. Condensation. And this is a process where gases or vapor are returned back to their original state or liquid state, and it is sent back to the earth through the process called precipitation. When you do that, you earn 1 mark. I hope that helps. So note it down in your writing part as we move on to the next question. Here we are, moving on to question 11. Aiko is in hospital. We have a picture here showing Aiko attached to a kidney machine. We all know the dialysis process that goes on when an individual has developed kidney issues or kidney malfunction. So that is the typical picture that is replicated here. Her kidneys do not work. Aiko is attached to a kidney machine as illustrated earlier. Explain how the kidney machine is helping Aiko. So if you have an idea of how dialysis is conducted in the hospital for an individual who has kidney or kidneys malfunction, that will give you the basic clue on how to answer this question. But basically, it has to do with how the blood is being filtered and cleansed from every impurities or toxic substances in order to keep the individual alive. So the possible response to this question could be that, 1, you could say to keep her alive or to keep Aiko alive, the machine keeps Aiko alive. The machine helps to remove waste from her body, or you could say the machine helps to filter her blood, or it helps to maintain the right amount of water in her body because it has to do with water regulation and the regulation of waste materials in the blood, which is in liquid form as well, in the blood. So I'll go with the following option. I believe you can write that down. You can say it keeps her alive. You could also say it helps to remove waste from her body, from her body. Another option could be that it helps to filter or cleanse her blood. You can say filter or cleanses her blood, and this helps her to stay alive for a very long period of time. This helps to stay alive as much as possible. So any of these options would go for 2 marks allocated. Is that noted? Or I put that down in your writing pad. You can pause the video at intervals to study the question again. Question 12 says, look at this list of materials. This is actually drawn from chemistry strand that has to do with uses of everyday materials that involves different states of matter, solid, liquid, or gaseous materials. It could be plastic, rubber, metal, or iron. Could be aluminium, could be clay, could be cotton, could be wool, and so on, including wood as well. But let's look at the question on the table before us. The column here represents different materials. We have material A, B, C, D, E, F, and material G. So they represent a particular material. It's our illustration and our analogy that will help us to fathom or decipher which one goes for what. So this represents the property across the rows. So we have one of the property here that says, is it hard? Is it flexible? Is it transparent? Is it a liquid at room temperature? Now we're going to answer these questions by looking at the responses already done for us here. So material A, is it hard? Yes. Material A, is it flexible? Yes. Is it transparent? It's not transparent. No. Is it a liquid at room temperature? No. Is material B hard? Yes. Is it flexible? No. Is it transparent? No. Is it a liquid at room temperature? No. At room temperature? No. Material C is hard, is flexible, is not transparent, and is not a liquid at room temperature. Material D is not hard, is not flexible, but it is transparent and is a liquid at room temperature from that interpretation. Then material E is not hard, but is flexible, is not transparent, and is not a liquid at room temperature. That's how you see the word no there. Then material F is hard, that's why you have yes. Is flexible, yes. Is transparent, yes, but it's not a liquid at room temperature. The material G, the last but not the least, is it hard? It is not hard. It is not flexible. It is also not transparent, but it is a liquid at room temperature. So begin to think of different materials that exist in these states or these conditions. Now, A says, which two materials are see-through? Remember the properties of see-through under light. Thus, we have transparent materials that are easily seen through. We have translucent and opaque materials. So, which two materials are see-through? So, let's go back to the table. Under, is it transparent? That's the property or characteristic or feature that relates to see-through. So, let's look at which materials are see-through from here. This one has material A is no, material B no, material C no, material D yes. So, we've gotten one. Material E no, material F yes. So the only see-through materials here are D and F, as you can see. So you come here and write D and F for 1 mark. So both has to be correct for 1 mark. Now the next question says, which material is water? When water is mentioned, what comes to mind? Looking at the states of matter, we have solids, liquids, gases, and plasma. So does water exist as solid, liquid, or gases? Of course, it exists as liquid. So let's go to the feature that has to do with, is it a liquid at room temperature? Now let's look at it. We have material A no, material B no, material C no, material D yes. But is it transparent? Yes. Then let's look at this other material that is a liquid at room temperature. G is a liquid, but it is not transparent. Can you see the comparison? The material that is most probably water in this collection of materials is material D, because it is liquid at room temperature and at the same time it is transparent. Remember, one of the properties of water is that it is transparent, it is odorless, it is colorless, and so on and so forth. So you come to this B part and write material D. Why? Because it is both liquid at room temperature and it is transparent. Material G is liquid at room temperature but not transparent, which does not qualify it as water, because water is transparent in nature unless the water is polluted or adulterated. So that is the answer. Then C part says material E is suitable to make clothes. Let's go to material E and study it again. Material E, is it hard? No. Is it flexible? Yes. So since the material is not hard, it is soft. Is it flexible? Yes. So it can be easily, sewn into, it can be easily hewn into clothing materials. Then is it transparent? No. Is it liquid at room temperature? No. So we don't need these qualities to make clothes. So material E is suitable to make clothes for these two major reasons, because it is not hard and it is flexible. Then let's read on. Let's read on. Write down the best two reasons why material E is suitable to make clothes. Number one is that, look at it, is it hard? It is not hard. So you can say it is not hard. Or you can say it is soft, so that it can be made into clothing or textile materials. Then another reason, look at material E again. Is it flexible? Yes, it is flexible. So you can say another reason why material E is suitable to make clothes is because it is flexible. From the table, you have your clue. It is flexible. It is flexible, or we can say also it is elastic, so that it can be made into that clothing material. But flexible is the most probable response here. When you do this correctly, you earn the 2 marks allotted. Is that okay? All right, note that down. Let's move to question 13 quickly. Question 13 reads, this is under physics, talking about light. Then it has a little bit of earth and space embedded. The sun appears to move across the sky during a day in summer. Summer is when the weather is extremely hot. The diagram shows different positions of the sun. So starting from this point, the sun position moved from this point to this point. At this point, it was seen here. It was seen at this position. It was seen here, and the sun kept moving up until this point. Now, this horizontal line here represents the surface of the Earth. So, having studied that model, let's look at the question that follows. Here are some sentences about the sun. Draw a line from each sentence to true or false. So, the question wants to test your knowledge about how the rotation and the revolution of the Earth causes a movement that reflects different position of the sun per time, per season, and how we can apply this knowledge to either true or false. So we are doing a matching activity here. So this is the sentence. It is midday when the sun is highest in the sky. Simply put, when the sun is directly above one's head at midday, which is 12 noon, is the sun highest in the sky or lowest in the sky? It is midday when the sun is highest in the sky. The answer is what? Is true. And that is when you see, the shadow cast to be short, because directly above your head, highest in the sky. The sun goes down in the west. Where does the sun rises from? The sun rises from the east and sets in the west. So that is also true. The next sentence reads, in winter, that's cold season, the sun is lower in the sky than in the summer. The answer is also true, because it is only in summer the sun is high above the sky, but in winter it is lower in the sky. Then in winter, the sun moves in the opposite direction. In winter, that's when the weather is extremely cold. Does the sun move in opposite direction? It's trying to say, does the sun move in an anti-clockwise manner? The answer is no, so it's false. So if you're able to match these sentences to true or false in this particular order, only 3 of them are true, 1 of them is false. You earn your 2 marks allocated to this question. Did you find that easy to comprehend? All right, pause the video and take out time to study the sentences again, get yourself acquainted with it, and do the matching in your notebook. Question 14 reads, Mike investigates the germination of seeds. This is taken from biology strand of Cambridge Science checkpoint. Germination of seeds, seed germination and propagation, to be precise. So Mike puts filter paper and cotton wool into 6 dishes. These are the sample or model 6 dishes. We have A, B, C, D, E, and F. He puts filter paper and cotton wool into 6 dishes. He puts 15 seeds into each dish. Let's count the seeds. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So verify that there are 15 seeds in each dishes when you count all through. Then he adds water to 3 of the dishes, puts the dishes in different places. Then he looks at the dishes after 4 days. So these dishes A to F were placed in different positions or places, and after 4 days he started his observation or investigation. Now here are his results from that experiment. So we have dish column where we have dish A to F, then water. Another feature here or criteria is the condition in which the seeds were placed, then number of seeds germinated after 4 days. So for A, he added water, yes. The condition, it was in a cold room in the dark. Number of seeds germinated after 4 days was 2. Then for dish B, he also added water. The condition was in a warm room with light. Please take note of the different conditions, and there is no result here. So I'll put a question mark for now. Then dish C, we added water as well. The condition in which it was placed is in a warm room in the dark. 10 seeds germinated after 4 days. Then for dish D, it didn't add water, that's why I have no here. And it was in a cold room in the dark. There was no germination, that's why we have 0. Then E, no water added. It was in a warm room with light. No germination occurred. So we're interpolating here. This is what we call interpolation, or when you are interpreting results on a table or table of value. Then dish F, no water was added. It was placed in a warm room in the dark. There was also no germination. So I haven't studied this trend, and going by his results, let's see the question that follows. Mike did not write down his results for dish B. That's why I indicated question mark here, because we are to find out what that result should be after the investigation or experiment. So here are his results for dish B. So dish B has been isolated here, and let's count the number of germination that occurs. So this is 1, this is 2, 3, 4, in no particular order, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 seeds germinated out of 15. The question now says, how many seeds germinated in dish B? As we can see from our count, 12 seeds germinated. So you do that and you get your 1 mark. The B part says, which conditions are needed for germination? This has to do with the conditions necessary for germination of seeds. Please take note, germination of seeds is different from when a plant is fully sprouted and is now undergoing photosynthesis. Photosynthesis will only occur when the plant already has leaves sprouted from its cotyledons. But for germination, germination can happen both in the room and also in the open, that is outside the environment, when certain conditions are met. So the question says, cycle all the correct answers. Which conditions are needed for germination of seeds? Now, germination, when the seed is being inserted or when the seed is buried into the soil, what are the conditions needed for germination? Is it cold, dark, light, no water, warmth, and water? This is not an option to go by. It doesn't require darkness. It doesn't require light at that stage because it has not sprouted yet and there are no leaves present that should undergo photosynthesis, as in the case of green plants with green leaves or green cotyledons. Then no water, warmth, and water. So of course, a seed needs water for it to germinate because water soaks up the body part of the seed and goes down into the cortex and the other parts such as the plumule. Now, you have warmth is one of them because seeds need warmth to germinate. They also need water. So each of these goes for 1 mark each to give you 2 marks as indicated here. Is that noted? Now we move on. Question 15 says there are craters on the surface of the moon. This is the Earth and space aspect of Cambridge Primary Science checkpoint. We call it Earth and space, or simply like your geography. That has to do with the study of the Earth and its environs and other elements in full interaction. So there are craters on the surface of the moon. The first question that comes to mind, what are craters? Students, what craters are simply holes that are created on the surface of celestial bodies due to the impact of collisions. They are simply holes that are created due to the impact of the collisions of different bodies in space. When bodies collide, it causes holes or craters on the surface of that body colliding. So this is a crater. You can see the hole that was created on the surface of this particular body in space or celestial body as the case may be. That's what we call a crater. Now the question goes, Blessy investigates how craters are made. Blessy smooths the surface of sand in a tray. So she's using a model to explain the concept of craters and how they are created in space when two or more celestial bodies collide with each other. Blessy also drops a stone into the sand, like hold it at a height and dropped it to see the impact it will create on the surface of the sand due to its weight or mass. Measures the size of the crater the stone makes in the sand. She repeats the method dropping the stone from different heights. Repeats the measurement for each height. So this is Blessy, and this model shows us how she tried to demonstrate how craters are created in space. Now we have the stone here. This is the sand and the surface of it, and this is the tray in which the sand was filled up. Now let's look at the question that follows. Here are her results. So this is the table of results. Height of drop in centimeter. So we're measuring the height of the stone dropped at a particular height in centimeter. So we have 20 centimeter height, 40 centimeter height, 60 centimeter height, 80 and 100 centimeter respectively. Then size of crater in millimeters, how it forms the impact or the hole on the surface of the sand in the model. So measurement for drop 1. At drop 1, she got 12 millimeters. Measurement for drop 2. So she performed dropping from each height twice. And you can tell why that is done in a repeated manner during experiment or investigation. It's for us to get precise, accurate, and fair results in most cases. Then she had 12 millimeters there at drop 1 and 11 millimeters. Then at 40 centimeter height, the crater form is 15 millimeters and 14 millimeters for the second drop. Then at height 60 centimeter, the size of the crater is 28 millimeters and the second drop gave us 26 millimeters. At height 80 centimeter, 32 millimeters size of crater and 30 millimeter size of crater for the drop 2. At 100 centimeter height, 33 millimeters size of crater was created, and for the second drop, 35 millimeters. So with this idea, let's look at the question that follows. What equipment does Blessy use to measure the size of the crater? So let's go back to the model again, or the image, as you can see. So if this drops here and forms a crater, how do you measure the height from here to here, or the distance or the size covered? So to do this, you will need to use a rule or ruler. Does that make sense? So you come here and write a rule, or you can say ruler. And when you do that, you earn your 1 mark. Another response could be the use of a measuring tape, or you can say a tape measure, and so on. It also goes for that. Now, the B part says, Blessy changes the height of the drop. That's the height of the drop on which the stone is dropped into the sand surface. Write down 2 factors Blessy keeps the same in her investigation. What does she need to keep the same in this investigation? Now, study the materials involved. Look at the stone. She's throwing it from a particular height. She has sand in a particular quantity or amount in this tray, and she has different heights she will throw from. So let's consider what other things she can keep the same, or what 2 factors can she keep the same. So I think one of it, from what I can see here, is the height of the stone. That's the height from here to here. That's why I did this arrow from this point to this point, the height. Then she can also keep the quantity of sand or soil in this tray from my own observation. You can observe other things you think she can keep the same, but the question requires only 2. So write down 2 factors Blessy keeps the same in her investigation. One of them will be to keep same quantity, same amount or quantity, same amount or quantity of sand so that it stays the same. Then you can also say she keeps the same size, or the same size of stone is most preferable for this response. Size of stone, same size of stone. Or you can say same mass of stones, so that it is maintained all through the experiment. So this goes for 1 mark. This goes for another 1 mark. So altogether it will amount to 2 marks. Is that noted? All right, let's move to the last question here. Rajiv dissolves a fertilizer in water. He records the mass of fertilizer that dissolves in 5 cubic cm of water. Take note. Rajiv makes measurements at 6 different temperatures. He shows his results in a graph. So take note of 6 different temperatures. Then it dissolves 5 cubic cm of fertilizer in water. So those are our major point or focal point here. He shows his result in a graph. So he draws this in a graph. On the vertical side of the graph, it represents the mass dissolved in grams. So from the origin of the graph, which is 0, you have 2 grids. That's 2 centimeter represents 10 units. Then we have 20, 30, and 40, then 50. Then we have on the horizontal side the temperature in degrees centigrade or Celsius. So using 2 centimeter for 10 units also, from the origin we have 10 degrees centigrade, 20 degrees centigrade, 30 degrees centigrade, 40 degrees centigrade, and 50 degrees centigrade. And he had plotted his results. You know, when you're studying graph, you need to be able to interpolate the results. You need to be able to match the points correctly in the appropriate way for you to get the required answer. At mass 20 grams, he recorded no rise in temperature, which is 0 degrees centigrade. Then at mass, let me trace this to the graph, it's broken lines. At mass 21, 22, at mass 22 grams, he recorded 10 degrees centigrade. So this is 22. Take note on the graph. Then let me trace this to the temperature. Let me trace this to the mass. So at 22, 23, at 20, 21, 22, 23, 24, 25, 26, 27, 21, 22. At 27 grams, he recorded 20 degrees centigrade of temperature rise. Then this point at 29 grams, he recorded 30 degrees centigrade. Then at mass 31, he recorded 40 degrees centigrade. Then at mass, trace it. This is 30, 31, 32, 33 grams. He recorded 50 degrees centigrade. Having studied this carefully from the markings, A says Rajiv wants to make his results more reliable. That's getting a reliable result. So there's two ways he can make his results more reliable. So let's go back to the process. He records the mass of fertilizer that dissolves in 5 cubic cm of water. Rajiv makes measurement at 6 different temperatures. He shows his results in a graph. So what two things can he do to make his test reliable? Owing to the variables he is working with here, talking about the mass of fertilizer, talking about temperatures as well, and the water that he used. You can get a clue from there by stating expected responses like he can repeat the experiment. He can repeat experiment, or in line with this, you can also say he can double check the experiment. He can repeat with more temperatures. We can say let him repeat or use more temperatures. Repeat with more temperatures. Just like adding more variables or more number of times the experiment is carried out to give a reliable result. So repeat with more temperatures. Temperatures. And any other analogy you can make from that introduction here. Okay, with that, I believe you are able to get the correct response and you earn 2 marks. Then the question B part says, describe the pattern of his result. So we'll go back to the graph and see the pattern. If you look at the pattern for the temperatures, it is from 10, 20, 30, 40, 50. So it is increasing. Then if you look at the mass dissolved in grams, from the origin 0, you have 10, 20, 30, 40, 50. So this gives me the idea that the increase in mass, or you could say the increase in temperature, leads to the increase in the mass of fertilizer dissolved in the water. So the pattern of result would be that the idea that the more the increase in temperature the increase in amount of fertilizer dissolved in water. So simply put, the higher the increase in temperature, the higher the increase in the amount of fertilizer dissolved in water, and that goes for 1 mark. The C part says, what mass of fertilizer is dissolved in 5 cubic cm of water at 30 degrees centigrade? So the idea here is for you to go back to the graph, then you trace from the temperature axis, which is the horizontal axis, to the vertical axis where the mass is represented, and take your reading. So this is how to go about it. Go back to the graph. Now you pick from 30 degrees centigrade and trace. That's why I used broken lines earlier. Use your ruler, use your transparent ruler to trace up to where it meets the line of best fit on the graph. Then you take it using broken lines again, using your ruler, and trace it to the mass axis. And what does that give us? That gives us, this is 20, 21, 22, 23, 24, 25, 26, 27, 28. That's 28 grams is the answer. I hope you understand how we got that. So here you write 28 grams. I'll take that again. From the 30 degrees centigrade point on the temperature scale or axis, use your broken lines with the aid of your transparent ruler and connect to the point where it meets on the best line of fit, and then trace it again to the mass axis, which is the vertical axis of this graph. Then you do your counting from here and take your reading. So it's exactly at 28. Oh, sorry about that. 28 grams. On this graph, 2 centimeter, this is 1 centimeter. From here to here is 1 centimeter. And from this other side of the grid is another 1 centimeter. So each line on the grid represents 1. So you count it as 1 and you keep going until you stop at the point where you are required to. So that gives us 28 grams as seen in the graph. Okay, that will take us to the D part. The D part says predict the mass of fertilizer that dissolves at 60 degrees centigrade. So we want to determine the mass of fertilizer that dissolves in water at temperature 60 degrees centigrade when increased by additional 10 degrees centigrade. So if you look at this graph, on the temperature axis, we don't have up to 60. So you can extend this graph just a bit and indicate 60 here. So this is my 60 degrees centigrade. Then you will now have to trace this to this graph. So I'll extend this graph this way. This is the way to go about it. Then we'll now take our readings eventually. This is just a rough sketch. You can do this neatly with your ruler by tracing. Is that okay? Alright, so I'm just going to be quick about this. I'm using my freehand sketch, so it might not be exactly straight, but we're going to use it to get our answer. Okay, so if this is the new graph, the extended graph, I can put my arrow here to show that it's increasing from the origin to 60 degrees centigrade above. Okay, so how do we now get, so I'll have to extend this line of best fit as well. I don't know how straight this can be. I will have to extend the line of best fit to the newly extended graph. Then, having done that, I will now go this way. Back to the question for clarity. Predict the mass of fertilizer that dissolves at 60 degrees centigrade. So just like we traced the mass of water, just like we traced the mass of fertilizer dissolved in 5 cubic cm of water at 30 degrees centigrade to get 28, it's the same method we're going to use by tracing it on the graph. So are we ready? And let's move to the graph. So from 60 degrees centigrade on the graph, use your transparent ruler and broken lines and go all the way up in a straight line. So where this touches the best line of fit, then you trace it to the graph. So this is the line. It's on this line. We keep going. I'm going to use, yeah, it's on this line. So I'm using broken lines now to trace it until I get to the mass axis. So here, if you have 30 here, this is 35, 36, 37. You get to 38, 39, and 40. So it's exactly at 37 grams here. So the range between 37 grams to say 40 can be a likable answer for this question, but I got exactly 37 grams and it's correct. So that goes for 1 mark. Your ability to do this, make you to earn all the points correctly. So if you have any challenges, you can pause this video at intervals and ensure you study the questions carefully, gain an understanding, process the information using your critical thinking skills, and then attempt the question in the most expected manner. With this, you're on your way to stardom. Have a great day. Bye.